Maybe I don't post this video. Maybe I do. Who knows? But the truth is that today should be day 13 of my um, coding, solving problems, videos, and the whole series I've been uploading to YouTube. The whole point since the first video was to keep track of my process, my learning process, everything I'm doing to prepare myself to be interview ready for the tech industry, right? We are in 2024. Everything out there seems to be brutal. I personally don't know because I haven't yet been out there in the market. But obviously, all we do is reading on Reddit and Twitter and whatnot, right? Everywhere is like, oh, the tech, industry is tough right now. And I get that. I mean, I'm not saying it's not. I totally get it. We know how the economy is. We know how inflation is making not just the economy, but everything else that's um, dollar based just go to absolute, absolute hell. And why am I talking about this in this channel, anyways? Well, this is the process of someone that really wants to land a job in computer science, especially like specifically software development. And I know there's thousands, hundreds of thousands probably out there doing the same thing. And I'm just trying to think, like, I remember watching not too long ago a podcast where Jeff Bezos comes on and he's talking about his friend in college, one of his friends, and this guy, I forget the name now. It's like this Deshanti or something like that. I don't remember the name. Sorry about that, but you can look it up. It's on Lex Friedman, Jeff Bezos. The last till this day, 2024, the last time he was on the show. But anyways, he's talking about how like he was going to college to be a theoretic physicist, right? He wanted to be basically a scientist, right? And study, you know, all the theories in physics that you can imagine. I'm talking about obviously deep math and physics and all these hard topics. Um, but then he found this guy that was like a master in this. He had an exercise that he had to solve, and him and one of his friends, not the actual guy, but one of his other friends, like spent hours trying to solve the problem, and they couldn't figure it out, and they brought it to this guy, and this guy was like, "Oh, the answer is pi," and they're both like, "What? Like, how did you just come up with that?" The guy's like, "No, I was solving problems one day, and it was similar to this, so I just figure out the pattern, and the answer is pi." And they went to a whiteboard and draw the problem out, and the result was pi. Anyways, why do I say this? Because Jeff Bezos did not end up being a theoretic physicist, right? Theoretic physicist. Um, he ended up being, you could say someone better, something better, whatever you want to say, right? Depends the point of view, depends where you're sitting on right now, right? Money is going to be always the number one thing for most people, so you want to be like, oh yeah, Jeff Bezos is not this other guy, but the whole point is that he's learning from that experience was that he wasn't ready to be that person. He wasn't ready to be as good as his friend was, right? And he took a step back and he said, I'm not going to be a theoretic physicist. I'm just going to try to figure something else. He ended up working in Wall Street, and then he left that to build Amazon, and we all know the story. But I was just thinking, like, when do you realize is the time for you to give up, right? When is the time that you realize that you're not good enough for something? When is the time when you realize that, maybe you're not too good for this, or maybe you're not enough for this, or whatever? I mean, maybe he would have stayed in the field and he would have been a great theoretic physicist. Who knows? But he didn't, right? That experience taught him something different. Now, it's kind of like paradoxic. I hope that's the right word. Um, but I'm trying to say it's a paradox, because then he went to struggle in Amazon for so many years, but he persisted and he became what we know now. He didn't give up on that dream, right? He pursued that dream until he was able to accomplish that dream. So again, the question is when. And the whole reason I'm talking about this for this long is just because I'm trying to provide value to whoever's in the other side based on my own experience, right? I started a web development company, and I run my company in the United States for 4 years. I'm originally from the Dominican Republic. I started my business there when I was, I don't know, like 22, and then I decided to come here. I got married, met my wife, obviously, before I got married. But I was working somewhere else, and then I decided to start my business again here. And doing all that, it's just been a great experience for me. And I just haven't been disciplined or strong enough to persist harder things in life, right? I'm very, very happy for where I'm at and the things I've accomplished. Like the fact that I'm talking to you right now, wherever you're from, in a different language that's not my language, just shows me a lot. Because when I got here, I was basically, blank. And the problem of today, to kind of sync this to, or link it to the whole point of this channel, the problem of today was valid Sudoku. It's the next problem, and I'm all over the place here and NeetCode, but this problem right here, based on this list, it's a medium problem. It's a matrix problem. In the previous video, I show how to transpose a matrix, and that was pretty insightful even for me, obviously. But then this problem kind of like I was beating my head against this problem because I was trying to understand certain things, and I see a pattern like in every problem I see on LeetCode. There's always like a little math trick you gotta know for something specific, right? And it kind of like bumps me down a little bit because I'm like, I'm not that good at math, okay? And I mean, I can solve the problems, but I need some more time. I need to warm up. Some people just have the brain connections already developed because their education or their topics in college or whatever were harder, and they went through it and they built the connection. Then those neurons are connected up there. But whatever the reason is, I just find it like very tedious to have to like solve a problem like valid Sudoku, right? And the problem, like, specifically have this formula to find the index of a box. And like in Sudoku, you have to, if you played the game before, I hope I didn't delete okay, no, it's right here. I'm just gonna pop it over here and show you. This is the problem, right? This is the grid in Sudoku, and basically what it says is, I'm all over the place here so you can tell, but basically the problem says you gotta find a, I'm trying to, here we go. Okay. So it says you're given a 9x9 Sudoku board, and the Sudoku board is valid if the following rules are followed, right? Let's actually go ahead and read it from LeetCode, because NeetCode kind of copies but leaves some things out to not infringe copyright. So basically says, the Sudoku board 9x9 is going to be valid if we get to approve the following 3 rules or limitations, right? If these 3 things are valid, then the Sudoku board is valid. So each row must contain digits from 1 to 9 without repetition. Each column must contain digits from 1 to 9 without repetition, and then each 3x3 out of the 9 subboxes of the grid must contain the digits 1 through 9 without repetition, okay? What are they talking about here, okay? Well, let's go ahead and come here, now that we know the problem. So they're saying, each specific row in this grid should be numbers from 1 to 9 without repetition. And there are 9 boxes if you count in a horizontal row all the way. There are 9 boxes, 3x3, right? Same thing here, blah, blah, blah. Same thing in columns, right? There are 3x3 in every column. So we're talking about rows, we're talking about columns, right? This is, by the way, a 2D array, right? We know this is a 2D array. A 2D array is just an array of arrays or a list of lists. And you just have to know how to traverse that, because you're walking through the list inside another list. So mainly you're going to use it's going to be a nested for loop. Will you say for every item in this board, and then you inside that say for every column in this board. And that's basically like the main way to do it. Rows, columns, and then whatever your operation you need to do here. That could be call out a cell, for instance. If you want cell, you set cell equals board, add that column, add that row. And that's like the pattern on this thing, okay? But again, we're solving puzzles. We're solving puzzles here. We gotta know these patterns. They're somehow related to real world projects, and we gotta know them, right? And that's the whole purpose of grinding LeetCode and all this, okay? But what happened is, going back to the problem, that we have to, besides traversing rows and columns, to find uniqueness in these numbers right here. So numbers from 1 to 9 that don't repeat itself. We also have to find a way to separate the whole thing into subboxes. Subboxes are nothing less than a row of 3 and a column of 3. And I kind of came here and did the same thing. So this is going to be a subbox, whatever is inside here. So notice how I have coordinates here. And this looks a little crazy, but I'll pass to explain it. So we see here that this little box right here, and I'm gonna pick a different color. We see that this little box right here contains 3 rows and 3 columns, and that's the same for all 9 of them. We have the same thing here, we have the same thing here, and we have the same thing repeated 3 times down there. Down here and down here. I'm going to delete that, but I just want to show. That is the representation of this. That's what you're seeing here. Okay? So what's happening is that this is the way for us to traverse rows and columns. this is how we go through I and J, and I have it marked here. I represents the column, and J represents the rows. I'll put these over here because I'll talk about these crap in a little bit. Anyways, so I represents the rows, J represents the columns. So when we're iterating, when I say here, sale, it's equal to the board at that row and that column, right? All I'm saying is inside of the main, remember this is a list of lists, right? Because the way to represent that in Python or any other language in Python is a list of lists. So you can see here we have the two brackets, which is a list inside of a list, yada, yada, yada. And all that is just the way to represent this. Same thing here, okay? So we're walking through every element here, and we can find uniqueness in that. Till that point, I get, we're solving the problem. We know we have to have a for loop, nested for loop to walk inside of a list. Now we also have to find a way to determine how these boxes are unique too. And why do we need uniqueness in these boxes? Well, because based on the rules of Sudoku that are very specific for Sudoku, we are traversing the whole list. And if we wouldn't need the subboxes here, which is the third rule right here, if we wouldn't need that, it would be a super easy problem, because all we gotta do is go one by one, where is that other board? Don't tell me I deleted it. Anyways, I guess I'd deleted that other board. I did. Anyways, I'll bring it over. Why not? Let's see here. Here we go. Not too far. So I just want to have it there. So anyways, if it was just the case of iterating over every row, right? We're going one by one, and then every column, we would find solution. We would find a quick solution based on the size of the grid, and it would be, let's say, one pass. It would be a linear time operation, right? You go of n, and that's easy. That's it. That's something we can do till certain extent, right? What happened is that the rule right here says, you also have to verify that everything inside this little subboxes, it's different too. So for instance, we know in this case right here, we know that there is no other elements that repeat itself in this whole row right here, right? Same thing if we look all of them in column wise, right? Nothing repeats itself. Nothing repeats all the way down, okay? I'm just doing the lines, but nothing is repeated, okay? So, but also what this thing is asking is like, hey, make sure that also in this little section right here, nothing repeats. Meaning, if I would have, I don't know, a 3 here, and I need a pen for that. If I would have like a 3 here, then even though if I would have a 3 there, it would crash on the column, and in the second column, and it would crash on the second row. But also, it's invalid because the little box has 2 repeated numbers, okay? So we have to have uniqueness for that too. Now, when I'm like trying to figure out this problem, I get to a point where I hit a wall and I'm like, how do you determine that? Well, there are coordinates. And these coordinates represent each one of this grid. So for instance, if I want to find, let's say, the coordinate of this number right here, if I want to find that coordinate specifically, remember this is just an array inside another array, or a 2D array, or a list of lists, whatever term you want to use. I think at this point we should make this thing simpler instead of more complicated, just to make it more scientific. But I also respect I also respect the formality behind it. Don't get me wrong. Um, I'm not trying to mess up with that. Um, I'm just saying there could be simpler ways to make all this happen. But because at the end of the day, I just think like everything we do in computer science is to build something better, a better product, a better software, a better security, a better system, a better something better and useful for the people. But we lose ourselves like trying to find this complex puzzles and things that I get the science behind it and it's beautiful. It's one of the reasons that drives me to do this. But it's also, this is part of a process in 2024 to get a job. And I'm not saying it should be easier. I'm just saying some of these things are like, come on. And I'll get there. I'll get there eventually. And I'm not talking about rocket science either, okay? Don't think I'm talking about something that's super complicated, but it's also a little annoying. But anyways, if I want to find this 6 right here, if I want to find that, well, I know I'm iterating inside a list of lists, as I mentioned, so all I'm going to do is, get to a point where my I, or row, is equal to this section right here. And inside this section, I'm going to make my J, which is my column, be this section right here. And I'm covering, remember this, I'm iterating, I'm keeping it outside of the squares. But I'm iterating number by number here, right? Remember, this is I, and this is J for all of them. So every time in our for loop we move the needle, these pointers change to each specific item, right? Okay, that's clear. So once I get to this guy right here, iterating one by one. Once I get to column row number 3, column number 4. And how do we determine that? Well, this is row 0, row 1, row 2, row 3, row 4, row 5, yada yada. We see how it increments from 0, 1, 2, 3, 4, 5 in rows. In columns, the same thing. If we go to the second item, which is columns, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So these are our columns. Same thing. We get to here. We are in row number 3, column number 4. And how do we know that? Well, row 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And 0, 3, 0, 1, 2, 3, and 4. Mess up there. Rows. We're talking about 3, the third row, and going by columns. Okay, I got confused there. See, my whole debacle with this thing. But anyways, third row, fourth column. Got that. Now we have to determine how to get this box, and the whole idea to get that box is, well, we're gonna take our item right here, which is our column, divided by 3, because we have a 3 by 3 board and it's multiples of 3, so we can see how it goes by 3. So 0, 3, and 6, right? The same thing here. We can see how it goes by 0, 3, and 6. Talking about rows and columns, okay? We would need like a whole little section like this to kind of show that, but I'll try to make it so it's a little more intuitive. Well, that's, what I hope so. Let's just flip this thing like that and put it over here somewhere. So that's the whole process about iterating this thing, right? And we're gonna try to find the numbers that every time we iterate, if we look at whatever is in here, is how we're gonna get to our elements. And I'm not trying to make this more complicated, but I'm also trying to make it more visual. So we move our thing and just remember, like, just imagine that these grids are moving. So anyways, in order for us to find this little box right here, we divide our columns in 3, multiply by 3, multiply the result of that by 3, and then we go ahead and add our rows divided by 3 with that. So we want to find this, we want to find the sub box where that 6 is, right? So to get that, we say, you know, we know the coordinates are going to be 3, 4. So we go ahead and say I is equal to 3. Here we go. So I is going to be equal to 3, so we just substitute all that, make it good. That's going to be equal to 0. We know that. We're just going to do it linear like this. Then we multiply that by 3. I'm just going to do it like this. So 3, we know that it's equal to 3, so I'm going to go ahead and put 1 here. That's the result. Times 3 plus j, which is equal to, let's go ahead and substitute j is equal to 4 divided by 3. And this is floor division. So we're gonna round down, I hope that's the right word, every element or every result, right? We're gonna find the floor. If it's 1.6, we care about the entire integer, not the floating point. So it's going to be 1, not 1.6. And we round down to, that's why it's floor division, right? Anyways. So 4 divided by 3 is going to be equal to 1. So we go ahead and put 1 there. Just to make it easier. So what do we have left? We have 1 times 3. It's equal to 3. So I'm going to pull the result here. That's a 3, and plus 1 is equal to 4. So that's the result. That's the formula to find that little grid. That little grid right here, where 6 is at right now, it's the 4th grid, right? And if we count starting from index 0, again, we're in a zero-base index language, starting from 0 right here, 1, 2, 3, and 4, and that's it. That's where our little 6 is at. Okay, that's just the formula to find, or to kind of label these boxes right here, and that's how basically we're going to confirm how we're going to separate these boxes. And my whole thing was like, how do you come up with that? You know, like how like someone that's studying this kind of stuff, it's going to come up with that. I'm gonna delete the whole thing without wanting that, because you're like, yeah, you can try to sit there, but unless you've seen this problem before or a similar problem before, this is marked as a meeting problem. But unless you've seen these kind of problems before, you are not coming up with that solution in 20 minutes. You either have to know what you're doing exactly to the point where, like, you either know something that anyone knows math-wise, because I'm talking about the first time, like the person that came up with this problem, the person that sat down and came up with this problem. What is the level of knowledge you gotta have? And I'm not talking, this is not complicated. I'm not saying this formula is complicated. I'm just saying, you have to know that at some point you're going to have to label the little box, the sub boxes. How do you come up with a way to label them? Okay? You have to think about, and the problem is very specific here. It's telling you it's a 9 by 9, you know, it's a 3 by 3, it's 1 to 9. So we're talking about multiples of 3 all the way, so you know that, yeah, you're, like, they're giving you the clues. They're saying, yeah, at some point you're going to have to divide by 3 and multiply by 3, and then hopefully all that together. Okay, yeah, you can think about that, but you're not going to come up with that the first time. You're not going to pull this one. You're not going to pull that answer out of your Exactly. You're not. And the reason you're not is because you have to know you have to know how to deal with this kind of data structures. You got to have previous knowledge. And that's just the whole thing. Like I was like, okay, like I was honestly I use Claude or whatever to do that, but I was like, let me ask GPT because I haven't done GPT in a while, and I was like, but how do you come up with that? I was like, hey, honestly, I was like, how is this established to begin with? How does someone get to that conclusion without seeing the problem before? I just want to know, like, how did you just determine that the formula is, hey, divide, multiply, add up together, and that's how you're gonna label those sub boxes? And that's just like the whole thing. I don't want to get like, I'm not mad. It's just annoying that this kind of problems are like, they're puzzles, they're fun, they're like, that's the whole point of it. I mean, I've learned a lot starting for this problem. I wish I could have be smarter and learned this thing sooner, in a sense of like putting the video out there with like the whole solution, like neat code and all these guys, which I know they're studying for this, but it's also like a little bit of like, I don't know. I don't know. It took me out of my mindset. I went back to some. I was like, what about if I just like start solving easy problems until like I feel more comfortable? And I'm like trying to solve two sum here, and I've been doing like medium problems and on leak code, and I'm like, let me try to solve two sum, an easy problem. And I'm like trying to solve two sum, and I'm like, I don't remember how to solve it. There's a specific pattern to solve it. Well, guess what? The pattern is, and you're gonna see I submitted this like over a year ago, but anyways, the pattern to solve this thing, it's again another mathematical trick. Look at this thing right here. Look at this beauty. I'm just gonna copy the whole thing and put it right here. There are other ways to solve all these problems, okay? But look at this thing. Look at this problem. Maybe this is not the best. This is not the best thing to do. I'm gonna do it right here. So we're creating a hash map, and you've probably seen this problem. We're creating a hash map to keep track of the indexes and the values, right? Because at the end they're saying return the index, return the index. Yeah. So find the sum between the two elements based on the target, and then return the index where the numbers are for the total of the target. Okay. So going back to the problem, I'm like trying to read it because I did a few iterations. I was using 2 pointers for this. I was using 2 pointers, one at the beginning, one at the end. If the sum was greater than the target, I would take the far end pointer down a level, because we know everything past that level is greater. If the sum was less, I would come up with this, and try to find the sum with these 2 pointers until the target was accomplished. And then I think I had a list where I was appending the index of the pointers if I found the result. Okay, it didn't work. But I come here and I'm like, oh, okay, I have a hash map. Yeah, okay, I want to keep track of index and values. Cool. So for every item and number in the list, find the difference. Okay, find the difference. What's the difference? Well, the difference is going to be the target number we're looking for. And let's go ahead and take like this example right here. So the difference is going to be 9 minus what number? We're at 2 right now. So 9 minus 2 is 7. So the difference equals 7. If 7 is in the hash map, then go ahead and return the key, which is the index in this case, right? Remember, we're iterating over indexing number. Go ahead and return the key at that 7, because the 7 is in the hash map, and also go ahead and return the index. Okay? The index we are on right now. So we're basically saying the index where the difference is, because we already saw that number and it's already stored in the hash map, in the index we are iterating on at the moment. Those two numbers should be equal to our target. If not, then just go ahead and add that number, You see right here, go ahead and add it to the hash map at that index. Or go ahead, we're using numbers as the key and index as the value. So, anyways, that's the solution. But I'm like, you had to come up with to find a difference. You had to think that you had to subtract. There's no process there. There's a mathematical trick. You have to find this little mathematical trick. And that, again, I'm not talking about something that is hard. I'm talking about like this is a trick, right? There's no process. You're not saying, oh, well, I have a hash map. Maybe if I can go ahead and add the numbers before adding it to the hash map, I can have a hash map. I don't know. I think you can have a hash map, and I'm just gonna, oops, I guess I closed my thing. I guess you can have a hash map where you have numbers and values. And I'm just gonna do a quick one right here. And you're gonna be adding, for instance, the first number we see is 2. The second number, let's say we sum 2 and 15, which that's gonna be 17. That's gonna be the sum of these two items, right? We're using this as the value. So we know that the index of this is going to be 0, right? And so on for the other examples. So like 7, and so we know that's greater than the target. The target is 9. So what do? We go ahead and go to 11. We keep our other pointer here. So we do the same thing. So 2 and 11. So we go ahead and do index 2. The sum is equal to 15. Anyways, keep track of the sum all the way up. This index right here is going to be 1. And I guess what I'm trying to say is this. Index 1, the sum is, or index 0, the sum is 17. Index 1, the sum is 15. At index 2, the sum is going to be 9. So we know at index 2, we found the sum. We are at index 0 in our main iterator right here in our main list, but inside or our left pointer, right pointer, far right pointer at the end, found the sum at index 2. So what do we return? We return at index 0. We found the sum at index 2. And that's it. That's the result, right? With no mathematical trick nor anything, just going ahead and using our hash map and returning the result we want. If you want to go with the hash map. I get it. That might be more efficient. The difference is more efficient. And you have to understand that, like, I'm literally putting myself out there. I could be talking from 100% point of ignorance, but I still think that I could post an opinion on this, because some of these things are just like annoying. Like, that's not the code I wanna. That's not how I want to show. That's not how I want to show an interview in my talent. You know, like, I'm able to build projects. I'm able to deliver. I'm able to do so many things. Like, I've worked so many projects now at this point in my agency that I know I can deliver great results. Customer relationships. I have a background in business before doing web development. So, like, I know I can deliver the value, and I know I have to know these things. I know they want me to prove that I know how to manipulate data structures, and I know, trade-off in time, complexity, space, complexity, and, I know some sorting algorithms and all that. I understand, like, cool. But this is, like, doing little math tricks is not how we're going to show them how we do things. And hopefully maybe you don't get that kind of question in your interview. Maybe you can just, show that you can brute force something, and it's going to work the same way. I don't know. I was just like sitting there contemplating. I'm like, am I just not good enough for this? Hey, and maybe not. Do I want to give up on it? No. I want to keep trying. I want to keep practicing. Um, I want to keep putting a lot of hard work in this, and I'm gonna do it. I'm gonna do it. But yeah, there's no problem solving today. Just this video. In the next video, though, I'm gonna solve valid Sudoku. I'm gonna be posting the solution with a little better approach. I don't even know if I'm gonna post this video, but if you got anything of value on it, if you if you disagree, if you agree, whatever, just let me know. Let me know. Let's talk about it. I think we should talk about it, definitely. But yeah, that's gonna be the video of today. Next video that I'm probably gonna record right after this one, it's going to be solving the problem. And yeah, if you want to see more, please subscribe to my channel, like the video. It really helps a lot. Helps a lot to continue my journey, to don't give up. Building in public, doing all this thing in public, knowing that at least one person is going to be on the other side watching this, really helps to stay on track and stay motivated beyond your thrive. So yeah, thanks a lot for watching, and I'll see you in the next video.